Hello, this time we're going to consider a proof of the product rule, an example, and a small application. So, let's start like this. Let f of x and g of x be differentiable functions. Then their product, f of x times g of x, is differentiable and its derivative with respect to x, it's given by this expression. Right? Now, let's give it a shot. Let's actually calculate the limits. Remember, the idea is that we're going to indicate, if possible, that the derivative of the product f times g at x, right, is nothing else but the limit as h goes to 0 by the definition of f times g evaluated at x plus h minus f times g evaluated at x all over h. Right? Here is just a definition of derivative. Now, after this one, I have the limit. I'm going to incorporate the definition of the product of two functions, and I'm going to write it in the following terms. I have f of x plus h times g of x plus h minus f of x times g of x. All of this divided by h. Well, then from here is where the actual trick comes into play. Because now I'm going to introduce a fancy zero. I'm going to still compute this limit, right? But I'll do it in the following way. I have f of x plus h times g of x plus h plus f of x plus h times g of x minus f of x plus h times g of x minus f of x times g of x. You may say, wait, all of this divided by h. You say, wait a second, right? That is just 0. Yes, that is just 0. But look, based on that observation, I can do the following. I can take the limit as h goes to 0 and then combine, well, the like terms. So for example, I can write f of x plus h times g of x plus h minus g of x all divided by h plus. Now I'm going to factor the following expression from, you see, this one goes with this one. So now this one that I'm underlining here will go with this one. And they have in common g of x. So I'm going to write it in the following fashion. So what is that we have? We have f of x plus h minus f of x over h times g of x. But now, properties of limits. Limits behave well under addition and multiplication. So I'm going to break this into the following. The limit as h goes to 0 of f of x plus h times the limit as h goes to 0 of g of x plus h minus g of x over h. And now this one plus the limit as h goes to 0 of f of x, not f of x, but directly f of x plus h minus f of x over h times the limit as h goes to 0 of g of x. Of course, over here, f being differentiable is also continuous. So this is nothing else but f of x itself. This one is by definition the derivative of g. So g prime of x. This one, by definition, is the derivative of f, so plus f prime of x. And this one, well, we compute the limit directly. There's no h involved in the expression in this limiting process, so really that is just a constant, right? So this is just times g of x, so even better. Oh, boom, we're done. We just demonstrated the formula and obtain a formula for computing the limit, the derivative of a product. Let's do an example of this. Right? So let's calculate the derivative with respect to x of the expression x squared times 6x squared plus 1. Well, based on the observations that we have done here, we have that this is x squared times the derivative with respect to x of 6x squared plus 1 plus the derivative with respect to x of x squared times 6x squared plus 1. Of course, this one is x squared times 12x plus 2x times 6x squared plus 1, which we can simplify to 12x cubed, plus 12x cubed plus 2x, which of course you can write as 24x cubed plus 2x, which if you have time, you can factor a 2x if you wish, right? And then obtain this in the following form as 16x squared plus 1. Oof. Okay, that saves a lot of work. That saves us from actually performing this product that we have here and computing the derivative one by one. But now, here's a small application. Probably you have seen that, well, certain products are very expensive and scarce. So let me put the following kind of imaginary, but not so far away from the reality situation. So at a certain day, egg production is declining at a rate of something like this, 30 eggs per day. But due to scarcity, price is rising at a rate say 50 cents per egg per day. You may say, well, what are the conditions on revenue? Is it increasing or decreasing? Well, who knows, right? But look, what do we know about revenue? Revenue is going to be the price times, well, the items that you're selling. And well, due to scarcity, everyone is looking to actually obtain those items. So all the items are going to be sold. And well, the price is the price. Well, who knows what that is? But let's see what happens. We want to know whether the revenue is increasing or decreasing, or what are the conditions here, right? Well, but to determine whether the revenue is increasing or decreasing, that corresponds to finding a derivative. So we want to know what this is, the prime of this. But based on the observation on the product rule, we have that this has to be the price times the derivative of the items plus the derivative of the price times the items. But then let me do the following. Based on the problem description that we have is that the price times negative 30 plus, well, 0.5 times items. So look, under what conditions is revenue increasing? Well, let's see. For that to happen, the derivative of revenue should be greater than 0, right? Meaning that the revenue is increasing. But what does it mean for us? Well, we have the following. We should have the following inequality. We have that negative 30 times the price plus 0.5 times the number of items is greater than 0. Right? That's the condition. Well, let's try to isolate all of this. And this time, this is equivalent as to say that 0.5 times the number of items, it's greater than 30 times the number of times the price. But then from here, I can get the following. I'm going to divide by 30. So I have, well, can I divide by 30? Well, whichever one. I can divide, for example, by 0.5. And then I get the following. I have items. It's greater than 60 times the price, which is the same as to say that items divided by the price is greater than 60. So as long as we keep this ratio greater than 60, well, revenue is going to increase. Similarly, when you have revenue decreasing, right? It's just similar analysis. So I hope that you like it. I mean, not something that we observe in terms of production, scarcity, and price tagging. So take care, subscribe, see ya.